You're going to have 3 problems, guys. So exam 0325 in person, open book.
If you're writing, we can't see it.
Oh, yeah, thanks. There you go. Open book, open notes, arrive by 9:15 a.m. in JMC 233/235, right? An exam was going to be for 1 hour, 15 minutes.
And you said 3 problems?
3 problems. And here's my gift to you. I'm going to tell you what the problems are going to be about. First problem, you're going to have conservation. Oh, did I use the word conservation? I didn't mean to. Angular momentum. All right. You will also have to use Newton's second law to find out forces and accelerations. So wink, wink. If the problem is asking you to find velocity, tensions in the string, accelerations, this is where you go, all right? Think, accelerations, tensions, forces. All right, so that's going to be your problem number 1. Second problem is going to be conservation of energy, or whenever I talk about conservation of energy, in my mind, friction in that equation, friction is conserved. We're just accounting for it, right? It's conserved in the universe. All right. But if you guys don't like that, and physicists come and shout at me, because they always come and shout at me, work energy principle, right? Basically, to me, these are the same thing. All right. You know, when I'm talking about Newton's second law and finding out accelerations, you will hear me use the word equilibrium a lot, right? Equilibrium, in a sense, it makes sense if you consider the mass times acceleration to be a force. It's called D'Alembert's principle. But anyways, I got into a fight recently with someone. All right, last question is going to be about either conservation of momentum for many bodies that hit each other. Right, and this could be either angular or linear, right? Or the problem could be about impulse momentum, right? And this would be for you're not for a system of particles, but for, like, you know what? Delete the last 10 seconds of the conversation. All right. So problem 1, problem 2, problem 3. You guys are swimming in so many problems. You have 3 homeworks, right? So you have homeworks 4, 5, and 6. By the way, homework 6 submission is today. All right, please submit it today so that I can post the solutions by tomorrow morning for these 3 homeworks. Then you've got problem sets going from week 5, class 1, up to week 8, class 1, or class 2. Which one was it? The one before rigid body, which one was it? Yeah, we get class 1. All right. So all of these, including these, all right. So these are all the problem sets. A lot of problems here, a lot of problems here. I've also posted extra exam problems on Brightspace. Did you guys see those?
Yeah, you just posted them yesterday or this
That's
morning?
right, yesterday. So you guys have enough problems. And always the approach to the problem solving stuff when you're looking at these solutions, because we all know how amazing the book solutions are, try setting the problem up yourself. Remember, everything in dynamics, what are your unknowns? Do I have enough number of equations to solve for these unknowns? How do I get these equations? Can I conserve angular momentum? Can I conserve energy? All right. Can I write out Newton's second law? All right. It's all about the number of equations equaling the number of unknowns. All right. That's all you have to be proficient in. So my suggestion to you is, if you guys, for those of you who haven't gone through and done these problems already, if you're short on time and you're like, crap, it takes a long time to solve these problems, try setting up all of these problems. At least just try setting up. Set up the unknowns, set up the equations, and be satisfied with knowing the fact that that is going to help you solve the problem. And then you can go back and look through the solutions to see if you were right in heading in the right direction or heading in the wrong direction. Again, another piece of advice: do not leave a blank answer sheet for a problem. Right? Just write your thoughts down. Draw the free body diagram. Draw stuff to show how it is looking before impact, after impact. What are the things that are going in? Draw to show what your different positions are where you're solving and looking at conservation of energy. Right? Different positions, I mean, like I'm finding velocity, position A, position B. This is what's going on. All right? Draw those things out. Remember how to find potential energy of things. How do you find a potential energy of a spring? How do you find a potential energy due to a change in height on the surface of the Earth? How do you find the potential energy between two galactic bodies, right? All of those things you need to know and be very, very comfortable with, all right? Having a datum line, going up is positive, going down is negative, right? All of those things you've got to be very, very well versed in, all right? Angular momentum is conserved when there's no forces or when I've got a central force acting, all right? What else? What questions do you guys have for me?
Can you scroll down what the third problem is about? So it's either going to be about conservation of momentum.
It's basically going to be about momentum. There you go. That's how you look at it.
Well, then you said slash impulse slash momentum. So
impulse momentum, right?
okay.
Would there be a problem on a system of particles?
Yes, maybe. It'll be either a problem on system of particles or a problem on impulse momentum for one particle.
Oh, okay.
I can do both if you guys want. We can do 4 problems. No, I'm just kidding. We're not going to do 4 problems. 3 problems is enough.
I was about to say, do you want to grade a 4th problem?
No, I don't. I really don't. That's a good. No, I don't. Nope. I don't want to grade 3. I was like, how can I automate this? I can't automate this because I can't. There's no way to grade for thinking by automating it. So, yeah. All right, bring your computers to use Mathematica if you need to for solving simultaneous equations. But remember, it's not imperative, right? Setting up will get you 90 to 95% of your grade. As long as the number of unknowns and the way you set the problem up is correct, you will get almost all of your grades, right? You only took 2 or 3 points off for not solving. So remember that. Guys, do you have any questions for me? If not, keep studying, keep practicing. We have an LA, no one came to the LA session yesterday, which I was okay with because the weather was so awesome. But tomorrow's LA session, the one before the exam, I will be there with Dan. So come to that if you guys have questions, last minute questions about things. All right. If you don't understand what the book solutions are, think of me as your book solutions translator. That's what I can help you do.
You got Dan to work on his vacation day?
I did, yeah. Well, probably not. He's probably going to throw a fit, but he doesn't. I don't know if he knows it yet, but yeah.
I was kind of bummed out to find our spring break is just one day.
Hey, the way you need to look at that is that one day is better than no days.
That's true. Very true.
As many universities